Hello, Assalamu alaikum. Are you all able to hear me? How are you all? All good?
Yes, miss.
Okay, today we are going to start off with a new topic that is going to be your stoichiometry, chemical reactions, and balancing equations. And then we're going to begin with some more concept after this. So let's start off with today's topic. Is the slide visible to everyone? Yes, is the slide visible to everyone?
Yes, miss.
Okay. So chemical reactions basically they involve reactants on one side and products. Basically, your reactants, supposingly if I say A and B, they react with each other, they are going to create a bond, okay, and that chemical bonding takes place as a result of which a new product is formed. Okay, so this new product can be a mixture, it can be a molecule, it can be a compound, but both of these reactants, if they're reacting and they're forming a new chemical bond, then you would say that this is a chemical compound which is formed with a new bond. So hence we say that this is a product. Okay. So reactants are on the left hand side of the period on the of the chemical reaction, whereas products they are on the right hand side of the chemical reaction. For instance, here in this case scenario, A and B they are your reactants, which are on the left hand side, and C is going to be your product. Okay, are we clear up to yet?
Yes, miss.
Okay, when we're writing word equations, there are different sort of equations. Like for instance, you would be either asked to write down a word equation or a chemical symbolic equation. Okay, when a word equation is asked, then you simply have to mention the name of the reactants and the products. Okay, you have to represent using words. Their full chemical names are to be represented. Okay, so for instance, if you look into this, it says sodium hydroxide reacts with hydrochloric acid to produce the product or to form sodium chloride and water. So what do we see here? We basically see that this is an alkali which is reacting with an acid. And if you know the general equation for acids and bases or acids and alkalis reacting with each other, they basically produce a salt and water. Okay. Generally, in the question paper, when you will be asked the complete words, they will be either given to you and you will be asked to write down the simple equation, or you will be given a certain case scenario where they are going to ask you to formulate a complete word equation whereby you are given the reactants and you will have to write down the products. Okay, for instance, if I ask you, um, can someone of you amongst you tell me the word equation for ammonia when it reacts with nitric acid? What does it form? Ammonia reacting with nitric acid, what does it form?
Ammonium nitrate.
Ammonium nitrate. Very good. So what are you going to write in the word equation? You will be writing ammonia. Sorry for the bad writing. It's going to react with nitric acid, and on the other hand side, that is your right hand side, you will have ammonium nitrate. Okay. Moving on to the simple equations. Simple equations, they basically utilize the chemical symbols. How are you going to get the chemical symbols? You will get the chemical symbols from the periodic table, which is usually given to you. Okay, which represents and you're going to represent the reactant in the product. For instance, it's the same. If you take the same example from the last one, sodium hydroxide is written as NaOH, which reacts with hydrochloric acid to produce a salt that is sodium chloride and water. Okay, now look into this. sodium hydroxide. How do we actually find out the formula of different chemical compounds? Hydroxide is OH minus. You should know the polyatomic ions, okay, and the monatomic ions both. So sodium ion is a monatomic ion here, okay, whereas hydroxide is basically a polyatomic ion. Monatomic basically means one particular atom is ionizing to form an ion, a cation here in this case scenario, so it forms sodium ions. Whereas hydroxide is oxygen and hydrogen. When both of them they react with each other, and they, as a result, they form a polyatomic ion of hydroxide, where overall charge is negative. So collectively, they have an overall charge in it. That is referred to as polyatomic ion. An ion which has multiple atoms coming together to form or to ionize, having an overall charge on it. Okay. For instance, you also have, can someone also name some other polyatomic ions? Sulfate, nitrate, and CO3 2 minus for carbonate, phosphate, okay, sulfide, nitrite. All of these are basically your polyatomic ions. You should know them, okay? So sodium hydroxide is a polyatomic ion. Last time, if you remember, I told you that whenever you have same charges on both the sides, you are simply going to cancel them out and write whatever is left behind. So NaOH is going to be the formula for sodium hydroxide, which reacts with hydrochloric acid. Again, if you look into this one, hydrochloric acid is basically H plus and Cl minus. Okay. So here again, you have same case scenario where you have equal number of equal valencies on both the sides, which you are going to cancel out, and then as a result you're going to write down the formula of HCl. When sodium hydroxide reacts with hydrochloric acid, the general equation says it forms salt and water. Okay, now salt is basically, if you look into the definition of a salt, salt is formed by when the hydrogen is basically in this acid molecule is replaced by the metal cation. Okay, so the formula of a salt basically involves the two parts. One part has to be the metal, the other part has to be the anion of the acid. Okay, and what is the anion of the acid here? Chloride. And the metal here is sodium. So NaCl will be the formula for the salt. Okay, plus water. Water, we know it is H2O. All right. So the simple equation is going to look like this. All right. Is this point clear so far?
Yes, miss.
If you look into the last one, I gave you another example of ammonia reacting with nitric acid. Can someone tell me the simple equation for this one? Ammonia. Ammonia is NH3. Yes, Ryan.
Miss, for sodium hydroxide,
No, for ammonia reacting with nitric acid.
NH3 plus.
Mm. Yes.
What's nitric acid?
Yeah.
HNO3.
HNO3, very good. Look, what is nitric acid? It is basically H positive ions and nitrate ions. Now, nitrate is NO3 minus. For this, you have to memorize these polyatomic ions. Okay, whenever you have same charges on both the sides, same valencies on both the sides, you're simply going to cancel them out and you're going to write whatever is left. So HNO3 is going to be nitric acid. And what is it going to form?
NH4NO3.
NH4NO3. Okay, so which is ammonium nitrate. Now, ammonium here is basically NH4 plus ions. This is a polyatomic ion as well. So ammonium ions are NH4 plus and nitrate is NO3 minus. This is basically an ammonium compound. Both of them, they have same valencies, so both of them, they will be cancelled out, and whatever is left will be written as the chemical formula. So NH4 NO3 is going to be your formula for ammonium nitrate. If you look into this equation, whenever a simple equation is written, there are three components. You should be writing correct formula for the respective substances. For instance, the reactants and the products. Okay. The next thing is you should be writing correct state symbols. Okay. And you should be, it shouldn't be an unbalanced chemical equation. It should be a chemically balanced. Okay. So this is particularly required that these three things should be fulfilled when you are writing down a chemically balanced equation. Whenever the question comes up where they are going to ask you regarding symbol equations, you have to ensure all of these. Okay. The reactants on the left hand side, the products on the right hand side, your state symbols, correct chemical formula, and chemically balanced equation. Okay. Now, when we're writing the state symbols, usually the there are certain things which are you can say they are known to us when we go through this whole syllabus. You should be knowing that metal compounds, they're usually solids, okay, except for a few exceptions. Ionic compounds, they are giant ionic lattices, which also means that they are solids, okay. Generally, non-metal compounds, they can be either solids, they can be liquids, or they can be gases. We will cover this in the periodic table, okay. So and precipitates, whenever precipitates they are formed in a solution, this means that it is an insoluble precipitate, so we have to write the state symbol of a solid. Okay, solids, they are to be represented as lowercase s, and the liquids are to be represented as a lowercase l, and gases are to be represented as a lowercase g, whereas aqueous solutions are to be represented as AQ. Okay, what does aqueous means? It means something which is dissolved, the solute which has been dissolved in a solvent to form a solution. Okay, any water soluble solution is going to be aqueous. Okay. Now, for instance, if you look into this equation, NaOH reacts with hydrochloric acid, it produces the salt and water. Ionic salts, they are going to be solid. So this salt is going to be solid. You will be writing lowercase s here. Water always has to be liquid. Okay, this is pure. And any pure liquid has to be small lowercase l. Okay. Sodium hydroxide, this is usually dissolved in water. This will be written as dilute sodium hydroxide or concentrated sodium hydroxide, which means that it is usually dissolved in water. You'll be writing AQ with it, and along with the HCl, you're also going to write AQ. So all of these state symbols, they have to be written as a subscript. For instance, you will be writing like this, NaCl, and this lowercase s has to be written like this. Is this point clear so far?
Yes, miss.
Okay, so for sometimes what happens, some of the substances which are usually given to you in the context of the question, they all tell you what's in which physical state it is present. Okay, for instance, if you don't know any physical state of a substance, or supposingly you are asked that ammonia reacts with hydrogen chloride gas, okay, it produces ammonium chloride. Okay. So ammonium chloride, they are going to say that solid ammonium chloride is produced as a result. So solid, either solid or illustration of a solution being formed or representation of this will be given to you in the context of the question. You have to pick from that question what is the particular state of matter, what is the physical state or the of that particular substance from the context of the question. Okay. What does combustion reaction means? Combustion means, yes, anybody?
A substance burning in oxygen to produce carbon dioxide.
Burning in oxygen to produce no, not carbon dioxide. If they are carbon containing compounds, then only they will be forming carbon dioxide in excess of oxygen which is present. Otherwise, if it is supposedly carbon is not present in in the substance, okay, and it is being burned, then what will be formed? Any substance which reacts with or undergoes burning reacts with oxygen, it produces its own oxide. Okay. So do we have any questions up till now?
Miss, for NaCl that you've written, isn't this in aqueous state mostly?
Sorry?
The NaCl that you have written, shouldn't this be in aqueous state?
Yeah, this should be an aqueous state. Yes, you're right. You're right. This will be aqueous sodium chloride which is formed. Yeah. Okay, moving on to the next one. So tell me one more. If magnesium oxide, supposingly, it reacts with, wait, let me just, magnesium oxide. The formula for magnesium oxide is going to be? Yes. What is the formula of magnesium oxide?
MgO.
MgO. Okay. And it reacts with nitric acid. Nitric acid is HNO3. What is it going to form?
Magnesium nitrate.
Magnesium nitrate and
And hydroxide.
hydroxide? Base, insoluble base is reacting with an acid to produce
Water.
water. Okay. Magnesium nitrate. What is the formula for magnesium nitrate?
MgNO3.
NO3 and nothing else.
Twice.
Yeah. So within brackets, it is going to be 2. How did we find out this formula? Magnesium is basically Mg2 plus. Okay. NO3 is minus for simple ionic compounds. We are going to swap these valencies and simply drag them down. Okay. Wait just a minute. Okay. So when you're going to swap these valencies and then you're going to drag them down, so this 2 will be written as a subscript with NO3. But since already 3 is mentioned as a number here, this 2 is going to come outside the brackets to represent that this number 2 is basically being multiplied with everything which is present within the brackets. Okay, so it is also multiplied with the oxygen atoms, also multiplied with the nitrogen atoms. Okay. And whereas -1 for nitrate will be, if when it is swapped and dragged down, it should be written with magnesium as a subscript. But usually 1 is not written as a subscript, which is why we skip it here. Okay. Is this point clear so far, how the formula of magnesium nitrate is formed?
Yes, Miss.
Okay. And then along with this, water is formed. Why? Because this is an insoluble base. It is reacting with an acid to produce a salt, and water will be formed as a result of the general equation. Okay. Now tell me the state symbols one by one. Magnesium oxide.
Gas.
No. What is magnesium oxide? This is an ionic compound. In the last one, we studied that ionic compounds, they are,
Solid.
yeah, they are usually solids until and otherwise they are written as that they're dissolved in water or anything else. Okay. So this is going to be your, this is an ionic compound. This is an insoluble base. Here, it is a solid magnesium oxide, which is going to react with nitric acid here. So dilute nitric acid. So this is going to be solid. Dilute nitric acid means that it is diluted in water. Okay. This means it has to be aqueous. Yes. Okay, very good. Then magnesium nitrate.
Solid.
How?
It is a salt.
Hmm?
It is a salt.
No, but all nitrates, they are soluble. Remember the solubility of the salts, the rules
Yeah,
for
all
solubility.
nitrates are soluble.
All
And,
nitrates are soluble. Whenever you see the nitrate which is written, all nitrates, all sodium compounds, all potassium compounds, and ammonium compounds. Amongst the cations, all of these, they are soluble. Their salts, when they are formed, they are all soluble. Okay. If this is written within the formula, that it means it has to be soluble. Okay. And if nitrate is written within the formula, it has to be completely soluble. So we are going to write aqueous here. Okay. Then water.
Liquid.
Water will be liquid. Very good. Okay. Pure substances, the pure liquids are going to be written as lowercase l. Okay. Tell me another one.
Miss, I have a question.
Yeah.
If we take sodium, for example, and we react it with oxygen, how are we going to, like, cross the valencies?
If sodium is reactive with the oxygen,
Yeah,
hmm,
like, I don't know, will it
it
become
burns an oxygen
NaO2?
basically.
Yeah, will it become Na2 or NaO2?
No, Na2O. Why NaO2? The valency for sodium is, it is present in group 1. The number of electrons lost or gain are written as the valency, right? And whereas oxygen is present in group 6 of the periodic table, so it means it is going to gain 2 electrons, right? You're going to swap and drag down these valencies. +1 is written, should be written as subscript with oxygen, whereas 2 will be written as subscript with sodium. So it will become Na2O. Okay.
Okay, so then we'll have to put the number 2 before Na2O because the oxygen molecules in the reactants was 2.
Yes. Then you have to balance it with the coefficients.
Okay, thanks.
Yeah. Okay. Moving on to, I haven't come yet till balancing of the equation. I'm just telling you regarding the chemical symbols. We're going to come on it. Okay. So let's take another example. Aluminum reacts with copper oxide, supposedly. What is it going to form? This is a metal displacement reaction. The most reactive metal is going to displace the less reactive one. Now, the most reactive one is aluminum here. It lies at the top of the reactivity series. It is going to displace the less reactive copper. Okay. Hence, it is going to form its own oxide. So, what is it going to become?
Aluminium oxide.
Yeah. And what will be the formula for aluminum oxide?
ALO.
ALO. Okay. Aluminum is 3 plus. Oxygen is 2 minus. What should be the formula?
Al23.
Al2O3. Yes, very good. Yes. So Al2O3 is the formula for aluminum oxide. Plus, what is the other byproduct? Can someone tell me? Can someone identify? I said, yeah. I said it's a metal displacement reaction. Yeah, copper. Who said that?
The process.
Okay, Basil, very good. So aluminum oxide is formed and copper is displaced. Okay. Aluminum is a more reactive metal. This is a metal displacement reaction. It reacts with copper oxide to produce its own oxide and displaces copper as a solid. Okay. Now tell me what will be the state symbols here in this case scenario. Aluminum will be
Solid.
solid. Metals, they are usually solid until otherwise stated, or is there if there is any exception for their state symbol in at room temperature and pressure. Okay. What about copper oxide?
Solid.
Solid. Very good. Excellent. And aluminum oxide?
Solid.
Solid. And this copper, which is also displaced, this is also going to be your solid copper, which is displaced. Okay. Now, if you see in this whole reaction, coming to your point, Zoya. So if you see in this chemical reaction here, you are able to identify that this is a chemically unbalanced equation. Okay. Not equal number of atoms are present on both the sides, right? On the reactant side and on the product side. So you should be balancing this chemical equation to have a chemically balanced equation. Okay. All right, there's one more thing. If the question gives you instructions regarding adding the state symbols, then you have to add in. Otherwise, they don't particularly give you instructions for adding state symbols, then you can skip it. Okay, since there is no marks for writing the state symbols. If you are going to be over efficiently writing the state symbols, okay, if they are correct, well, good. Okay, but if they are not correct and they're incorrect, then this might give the examiner a bad impression of yours. Okay, so moving on to how do we balance this equation? Can someone tell me which atoms are or which elements they're basically imbalanced here?
Aluminium and oxygen.
And oxygen, yes. Okay, so what do we do?
We put 2 next to the Al,
Okay, 2 next to Al.
and then we put 3 next to copper oxide.
Okay, now we have more copper atoms on the left, less on the right, which means that we need to be adding a coefficient with adjacent to copper on the right.
Yes.
Yeah. So we should add a 3 here in this case scenario. Okay, now this whole equation is completely balanced. 2 aluminum, 3 oxygens, and 3 copper atoms on both the sides. Are we clear? Do we have any questions so far? Okay, look at one more. Aluminum burns in chlorine. Chlorine, what should I write as a symbol equation for chlorine? Should be the, yeah,
Gas.
no, the symbol for it.
Cl.
Cl, and it is a diatomic molecule.
Cl2.
Halogens, yeah, specifically the gaseous halogens, they basically exist as their diatomic molecules, or halogens generally they are diatomic molecules, exist at room temperature as diatomic molecules. Group 8 are basically noble gases, which are monoatomic, since they don't really tend to react. So aluminum burns in chlorine to form its white solid aluminum chloride. Okay, aluminum chloride, where the formula for it would look like, yes,
AlCl3.
yes, very good, AlCl3. Now tell me the state symbols for each of them.
Al is solid.
Al is solid, it is a metal, very good. Chlorine,
Liquid.
no.
Gas.
Fluorine, yeah. At room temperature and pressure, fluorine and chlorine, they exist as gaseous diatomic molecules. Okay, bromine is a liquid, and iodine and the rest, they are solids. So this basically tends to show a, characteristic property of the halogens, that is group 7 atoms, that as we go down the group, we see that all of the atoms or elements, they're basically changing their state of matter from liquids to gases to from gases to liquids to solids. Aluminum chloride, what is this going to be?
Solid.
Solid, very good. I said aluminum burns in chlorine to form the white solid aluminum chloride. So in the context of the question, you were given the state symbol for this particular product which is formed. Okay, sometimes when you aren't sure about it, you should read the context of the question over and over again to get to the core of it. Okay, is this equation balanced?
No.
No. What do we do then?
We put a 3 next to the reaction side of Cl.
Okay, this means 3, this coefficient 3 means it is being multiplied with this 2. So to a total of 6 chlorine atoms are now here on the left hand side.
Then we put 2 with aluminium chloride on the product side.
On the product side, okay.
And
So
then
n-
we put 6 with aluminium on the reactant side.
why 6 on the reactant side? This would make it more aluminum on the reactant side.
Oh, sorry, we put 2.
2, yes. So 2 aluminum on the reactant side and 2 on the right hand side, and this 2 is basically being multiplied with all of these atoms, with aluminum as well and along with a chlorine. Okay, is this point clear so far? Any questions up till yet? Yes, any questions, any queries so far? Ayla, Ibrahim, Basit, Ahmed, Rayan, Shafi, and
No
Zoya.
questions.
Okay. So balancing chemical equations, it requires and shows that the same number of each type of atom appears to be on the both side of the equation, that is your reactant side and the product side. And using coefficients, we use it to balance, but we do not change the actual chemical formula. Okay, we'll be looking into the molecular formula and the different type of formulas. Acid-base reactions, where acid reacts with a base. Redox reactions, which basically involves the transfer of electrons. One of the examples of redox is electrolysis as well. When we see chemical reactions taking place at the electrodes, that is the cathode and the anode, we will do this in your electrolysis. Then you have precipitation reactions, which results in the formation of an insoluble product. For instance, you can say I say that silver nitrate is AgNO3. Ag is 1 plus, NO3 is minus. Both of them have same valency, so they will be cancelled out. Whatever is left will be written. It reacts with NaCl, okay, to produce insoluble precipitate of silver chloride, AgCl. Okay. How is the formula AgCl? Because it is again plus and this is minus. Okay. It produces AgCl, and what else will be produced? When AgNO3 reacts with NaCl, what else is produced? What will be the next byproduct? What is left behind?
NaNO3.
Yes. Sodium and nitrate ions are left behind. Both of them, they are going to react with each other to produce sodium nitrate. Na is 1 plus, NO3 is also minus 1. So both of the valencies, they cancel out each other. As a result, we get the formula of NaNO3. Now, if you look into this, can someone tell me what will be the state symbols? AgNO3 should be?
Yes.
Aqueous. Yes, very good. Why?
Because it has nitrate and no
Nitrate, yes. All nitrates, they are soluble. This has sodium, which is why this is also going to be aqueous, okay? AgNO3 reacts with dilute sodium chloride to form insoluble precipitate. Now, insoluble precipitates, they have to be solids. They are not dissolvable. So, this is going to be, AgCl is going to be a solid. And what about sodium nitrate?
aqueous.
Aqueous, very good. This is again a nitrate and also has sodium ions. So obviously this is going to be aqueous as well. Now, if you look into this, is this a chemically balanced equation?
Yes.
Yes, it is. We don't need to do anything here. Okay, so far. So this is an example of precipitation reaction. Acid-base neutralization, we've done this. Redox reactions such as these, they basically involve the transfer of the electrons and also you can say loss and gain of oxidation and reduction reactions, which are basically taking place in this case scenario. Okay. Now moving on to the empirical formula and the molecular formula. Empirical formula basically is the simplest whole number ratio of the atoms which are present in a chemical compound. Okay. So all the atoms which are present in a chemical compound must be in their simplest whole number ratio. Otherwise, it won't be the empirical formula. Okay. For instance, if I say CH4, this means that the carbon atoms, they are 1, 2, 4 of hydrogen atoms in this particular compound of CH4, right, of methane. And this is the simplest whole number ratio of both of these atoms which are present in this compound. You cannot further simplify them. So this will be the empirical formula of methane. Whereas molecular formula shows the actual number of atoms which are present in a particular molecule. Okay. For instance, if I say C2H6, it represents or tells you that the actual number of atoms which are present in this molecule is basically 2 carbon atoms and 6 hydrogen atoms. These are the actual number of atoms. You really don't need to look into the different aspects or the different functional groups or anything else in this particular formula. Molecular formula always has to be a clear representation of the actual number of atoms which are present in a particular molecule. You're going to identify the simply the atoms which are present in that particular molecule or compound. You're going to write those atoms, and you will be counting all the atoms by far for each different elements which are present, and you'll be simply writing them as a subscript within the molecular formula. Can these two be simplified furthermore? C2H6, can this be further simplified?
Yes.
Yes, it can be 1:3.
3.
So this means the empirical formula has to be CH3. The empirical formula of C2H6, which is basically an alkane, an organic compound, is going to be this empirical formula, which is CH3. Whereas the molecular formula, which is the actual representation of the atoms present in a molecule, is C2H6. Is CH4 a molecular formula as well? Or is it just the empirical formula?
It can be a molecular formula as well.
It can be a molecular formula as well. How?
Because it cannot be further simplified.
Yes, it cannot be further simplified. Okay, and no, the this answer is basically for the empirical formula. It cannot be further simplified, which is why it is the empirical formula. But it is the molecular formula since it shows the clear representation of the actual number of atoms. There are no more other atoms which are added into this molecule. Okay, this is the actual representation of the number of atoms which are present in this methane molecule. All right. If I ask you to tell me the chemical formula of ethanoic acid, it is basically CH3 COOH. Now COOH basically here is the functional group of this acid. Okay, this is a weak acid. What will be its molecular formula? How the molecular formula will be written? Yes, how is the molecular formula written?
CH2O.
Molecular formula.
Oh, okay. So that'll be C2H4O2.
Yes, very good. C2H4O2. And when you're going to write down you're simply going to add up all of the atoms which are present in this particular molecule and simply write it as a subscript to these atoms. And the empirical formula is going to be CH2O, which you said earlier, which is the simplest whole number ratio of these. Okay. Look into this one. Relative formula masses. Relative formula masses and relative molecular masses. Relative molecular masses, they are basically the sum of the relative atomic masses of all the atoms which are present in a particular molecule. Now, whenever there is a particular molecule, okay, and the atoms which are present in that particular molecule, they have their own certain relative atomic mass, which is given to you in the periodic table. You always have to refer to the periodic table and sum up their relative atomic masses to give you the actual relative molecular mass for that particular compound. But this terminology is different whenever the ionic compound is given to you. For the ionic compound, it has to be the relative formula masses. Why? Because there are formula units which are comprising of this ionic compound. Okay, so only the terminology is different. For ionic compounds, it is relative formula masses. For covalent compounds, it is relative molecular masses. However, the calculation is the same for any of these. Okay. So whenever we have to calculate the MR or the relative molecular masses, it is basically the sum of the AR of all the atoms present in that particular compound. For instance, if you look into the molecule water, that is H2O. So there are two hydrogen atoms, one oxygen atom. Okay, you're going to add up 2 times 1. 1 is the relative atomic mass of hydrogen if you look into the periodic table, plus 1 times oxygen. The relative atomic mass of oxygen is 16. You're going to sum it up. You will get the relative molecular mass, which is 18. Potassium carbonate, K2CO3. Okay, these are very easy. Let me just ask you any other. For instance, let's take magnesium nitrate. Can someone find out the MR of magnesium nitrate? How many magnesium atoms do we have?
1.
1. So, so AR of magnesium is relative atomic mass of magnesium is 24. Plus, how many nitrogen atoms do we have?
1.
No, we have 2 nitrogen atoms. This 2 will be multiplied with all the atoms which are present within the bracket. Okay, so 2 times 1, which is going to be 2 times the nitrogen's relative atomic mass. Okay, what is it? 14. 14 is the atomic mass of nitrogen. Plus, how many oxygen atoms do we have?
6.
6. Very good. So 16 times 6. Okay. What is the final answer? 16 times 6 plus 2 times 14 plus 24. Yes. Does anyone have calculators nearby?
148.
148. So this is how you're going to find out the relative molecular mass of a particular compound. Okay. It is basically the sum of all the atoms present in the chemical formula. Okay.
Does it
I
have
think we
any?
did. Yeah. Yes, Zoya.
Does it have any unit?
It does not have any unit. Relative atomic masses and relative molecular masses are unitless. Why? Because they're simply the ratios of it. Relative atomic masses, they are the ratios of the, what do you call it? It is basically the average weight of that particular of all the collective isotopes which are given to you, okay, or which basically exist on the planet Earth for that particular element. And when you average it out, it is basically compared to the average mass of a carbon 12 atom, and that is completely 12 units. It is 12 units. Okay, so which is why both of them, their ratios and ratios do not have units. So relative atomic masses and relative molecular masses, they do not have any units.
Okay, next.
Do we have any questions so far? Yes. Yes, any questions up till yet? Okay, if there are no questions, I will be ending the session till here for now. And inshallah, we will begin tomorrow. Take care. Allah Hafiz. Thank you. Bye-bye.
Allah Hafiz. Thank you.
Allah
Bye.
Hafiz.
That was.
Allah Hafiz.
Allah Hafiz.